Alrighty, hello everybody and welcome back. Welcome back. Okay, so I am building a warship. Another one. This one's a lot smaller. As you can see, it's like half the size, a third of the size of the last one I built. That was a big laggy mess. This isn't going to be a big laggy mess. I have another little patrol boat, which is half of this size. But I thought, okay, let's build something like this. And I mean, just, you know, it could be like a medium range SAR, whatever, which, so haven't focused on the inside too much yet. It's still kind of a shell. But what we do have are the most important things, which are the guns. And I was just going to calibrate the radar. So I was on my channel, and someone asked me a simple but complicated question. And that was, how do I scale elevation into my radar? So what I'm going to do is I'm going to spawn the ship into the world. Alright. And then we're going to take a look at the radar itself. So these are the two radars. Oh, I need the rotation and I need the compass. Hold on, these are almost the radars. These are almost the radars. We need the rotation in from the radar. So if you've done the super simple radar build, this black microcontroller is from that build. The second microcontroller is a radar build I did a long time ago, and it has some more code in it that I didn't add into the super simple. This is like, we're kind of getting to a little more complicated stuff, right? And I'll explain that as we go. Okay, and this one needs the compass as well because it gives us our ship rotation. Yeah, I went through it and I added a whole bunch of stuff to it that I didn't do in the super simple one. So there's our compass. Okay, so we'll save that. I don't know what, my computer's doing something, so hopefully it's gonna look all right. All right. So we have two different radars here. I think it's supposed to be north and that's supposed to be south. So we have two different radars here. This radar here, you see it's detecting objects and it's just giving us a little blip. This radar here, it's detecting objects. It's giving us a square. I have to do one more thing here. It's giving us a square, but what it's also doing is it's printing the altitude of the object. All right, so it prints a square here and it gives us this altitude final, and I had to multiply it by 10 because the altitude number it gives us is in meters and I wanted it to be in kilometers, or I don't know what it was. There's a math somewhere there's math that figures that out. In all of this, there's math somewhere that figures it out. Okay, so what I wanted to do was change the color. It's black. We'll just do this. And we'll do that for a couple of targets here, because I want you to see what it prints. Alright, perfect. So we'll update that and then we'll go through how it works. So when you're developing your radar, you're developing it, basically you're building a compass. So the radar is flat. Right? So in this case, the radar is flat, we have our angle, and the radar is flat, and we have our angle. Let's see. So we go to composite. The radar is giving us the distance to the target. Now, that distance isn't based on, it's a straight line. So if we pulled out our map and we just selected a point on the map, and you notice how it gives us our distance in a straight line, that's what that distance is. That's a straight line between you and the detected object. All right? Then it gives us our azimuth angle, and then it gives us the elevation angle. So I don't use the elevation angle for calculating the x, y of the object. I only need the azimuth angle, because the azimuth angle is the angle of rotation between us and the object that we're trying to detect. Okay? But that's on a flat plane. So by a flat plane, what I mean is that when we're doing our math, okay. So we detect the object, okay. That's this one here. It gives us our azimuth angle, which is our pivot. That's this number here, okay. It also, we need to take the distance. What I'm doing is I'm dividing the distance by the radius. And then we need to convert the angle, this pivot angle, we need to convert the azimuth into degrees. So what we do is we take it, we multiply it by 360, which is a circle, and then we divide it by half a circle, which allows us to put it onto a flat plane. And this is where if I divide this by, say, 360, I might be able to get it to a circle, and that's when we're doing XYZ to XYZ. That's more complicated, and I'll have to do a little bit more research to refresh myself before I can make a video where I teach people, because it'll probably be wrong, okay? So once we've converted that angle into degrees, we can then graph it onto our compass using the X and the Y value. To do that, we need sine and cosine, and then we need to take the degree of rotation, and we need our angle. Now, I don't know if we need this degree of rotation or the angle. I think only if I was drawing, I can't remember where this exactly comes into, but I'll have to figure it out. I'll have to figure that out in one I built without this, and one I built with it, and I can't remember where that goes. So I do apologize on that, okay? So, why does this matter? Why do we need the XY? Well, when we draw a line onto the screen, we need to go from the center of the screen, or our starting point, to the end point. In order to get the end point, the X and Y value, we need to have an input. So that's basically what we're doing. So we're taking the distance between us and the detected object. We're taking the azimuth angle, which is the angle between us and the detected object, which thankfully they do that math for us. We don't have to, otherwise I'd have to build an azimuth calculator and add it to the radar, but I don't have to. It's already programmed in there. Then we take that angle, which is a combination of the angle of rotation and our distance, and we convert it into degrees. Oh no, we just take the pivot and we convert it into degrees. Then we need the distance to tell us how far from the center of the screen to the X value, how far from the center of the screen to the Y value. And that's how we're able to draw the detected object, the X and Y of the detected object, based on where we are on a screen. Because you have to think about it, a screen is flat. It's flat. So wherever my mouse is, there's an X and Y value for that. As I move it around the screen, we could find the X and Y value. And then what we could do is I could make a dot in the center of the screen, and then I could draw a line from that dot to wherever my mouse is as I'm moving it around the screen. So it just takes a bit of math to be able to do that. So that's what we do. Now, what's not in this math is the elevation of the object. So, why? Because that was just a super simple radar, and I didn't want to get too complicated, because it's another 30 or 40 minutes trying to explain this. So now we get into, we have this here. I just wanted to show it. So it gives us our angle of elevation, which is its own input, okay? We need to take that angle of elevation, similar to the azimuth, but in this case, we need to multiply it by tan. So we take the distance between us and the detected object, we multiply that by tangent angle, which is here, our altitude angle. And then what we're able to do is we're actually able to just print that. That gives us the elevation. That'll give us the elevation, and it gives it to us in meters. So that's where, when you're designing your radar, and this is why I didn't kind of include it in this radar, was that there's a little bit more information that you need to print on the screen. All I wanted to do was make a radar that made a dot on the screen where the detected object was, and that's what I've done here. But in the earlier radars, I made it so that way it drew a line to the object, and then it had a square where the object was, as you can see, and then it prints information, and I wanted it to print the elevation and all that sort of stuff. So, to conclude this, if you want to add elevation to your radar, you need to take the elevation number that you're given from the radar, and then you need to take the distance and you need to multiply it by math.tangent that elevation number. And what that will do is that will give you a number. That'll give you a number. Now 255255 is black. So what I want to do is I need to look here at the Lua, and I just need to see blue is 00255. Okay, so we'll change this because I want to be able to see it so you guys can see it, what it's printing here. So then the elevation is in meters, and I just multiplied it by 10, just I guess for whatever reason. It's still, oh yeah, it only comes up. It's just a little blip. Yeah, let's see if I can. I'll tell it not to print the rest. I'll tell it not to print these ones here. There we go. So basically it says if there's a target and it's been detected, it draws a line, then it draws a rectangle around the object. But of course it's starting at the X and the Y. So at the top left corner of the square is where the actual object is. And then it gives me the distance as a number, and it gives me the altitude as a number. So this is where I was able to calculate that. I calibrated it. This is my lead up to when you go to space and you need to make the XYZ to XYZ. So, oh yeah, whatever. Anyways, it's not working. What is going on? Why is it printing? Is it printing these also? Oh, this is the compass here. Oh, whoops. So this is the compass here. Then what's this? EFGH. Oh, this is the rest of the target. So we can actually just do that. We don't need that. But this is our rotation. So let's just do that instead. Yeah, that should work hopefully. And from map, yeah, that should work hopefully. Perfect. Yeah, so I was trying to put a compass on there, on the map, and a few other things. I guess I just... Oh, now we're getting nothing. Yeah, see, so you see the blips there? If I calibrate the radar so that way it just, let's see. If it's stationary, here, that's what we'll do. We'll make it be static. Static, and then sweep speed, sweep limit, and then it should just move like this. It should just oscillate back and forth. When I turn it on, and then we should be able to see where we are within that object. Yeah, there you see. I have to move in order for it to detect me. But then you can see there, it's printing my elevation, and it's printing my distance. See, the elevation is negative, and what's the distance there? 52 it looks like. So that's kind of how that works. So I was saying, so once you have that elevation number, what you can then do on your super simple radar is when it detects the object, you can have a scale between 40,000, which is our maximum, and 0, which is sea level. And you can change the size of the detected object based on that, okay? So if you have the super simple radar, this is our super simple radar. This, go into the Lua here, this is the super simple. So what we need to do is we need to add the elevation here, right? So to do that, we need to get, we need to find what number that's going to be. So we go to our composites, and we need to look at the radar, and it's going to be channel 3, 1 distance, 2 azimuth angle, 3 elevation angle. So that's going to be 3. And what I'll do is I'll put a link in this video to the super simple radar tutorial. So you can take a look at it, you can build the Lua, and then you can add this. Okay, and then, all right. So we need number 3. So you notice how we said input get number 2, 6, 10. We actually skipped that, right? So now what we want to do is we want to say altitude, A, and then B, C, D, E, F, where we're going to go to H, G, and then A, L, T, H, right? And so this is going to equal input dot get number, and that's going to be number 3. So now we need to add 4, so that'll be 7, and that'll be 11, and that will be 15, and that will be 19. I'm just double checking to make sure I'm not reusing these numbers. And then that will be, what, 23? And that should be 27. And this should be 31. Because this would be number 1, number 2, number 3. Now, where is number 4? 1, 2, 3. Number 4 we're not using. Then we go 5, 6, 7. Cool. 9, 10, 11. Okay, so now you're starting to see the association of the numbers that we're picking up from the radar. Okay, so now what we need to do is we need to say alt number equals, and we need to take the distance and we need to multiply that by math.tan, and then we need to multiply that by the altitude. Just like that. One, two, 1, 2, 3, 4, 5, 6, 7, 8. All right, A, B, C, D, E, F, G, H, and then of course this is what has to change here, because these are each object that we detect. And now what we can do, when we print it onto the screen, see, it's going to draw a line to set color, and then it draws a line to the object. So what we can also do is we can, instead of drawing a line, we can tell it to draw a circle. And then we just need the X and the Y and the radius. So we can say if, let's see, we can say if our altitude number is greater than, Canadian keyboard, is greater than, let's say, because now what we need to do is we need to find a scale, right? We need to find a scale. So basically we would need to, if 40,000 is our maximum height, we need to divide this. We need to divide this by 40,000. I guess it doesn't really matter. It's the same thing as what we're doing here. So now what we need to do is we need to create a scale. So if we divide it by 40,000, then the number will be greater or smaller. It's the same thing, I guess, within that realm, right? I guess it's the same thing. So now the thing to watch is that it gives you this number in meters. So if you want the precise measurement in meters, you've got it. Now I don't know how high aircraft fly, but 40,000 is our maximum elevation, and then you're into space, right? So that's why I'm saying that if we take 40,000 and we try and scale that, now you kind of see the it's just going to take a little more thought. I guess not really, because it's based on this. It's based on this number. So if we take this number, we divide it by 40,000. Let's see, we do that. And we divide that by 40,000. That would give us a scalable number. Yeah, pretty much. This is our, what is that, 40,000 kilometers, not meters. Not meters. Right, that's why we had to multiply this by 10 and then divide it by 40,000. There we go. Okay, because it gives us the value in meters, but then that means your minimum detection, right? So that's why it's difficult to scale it, because now your minimum value is going to be 1 kilometer. So then what we need to do is that's where we need to set up this. If it's less than 1 kilometer, which would be when you think about it, our theoretical, our effective detectable range, right? Now, if it's PvP and you're trying to detect other players, obviously you want the full range that you can. But when you're if we want this to be like a PvE type setup where we're only detecting the enemy, the NPCs, then I think they only fly out to about 250 or maybe 300. I'm not sure, but that's where you would have to scale this, right? The radar that I build, the effective range is about 2 kilometers. So for me, I think, that's decent. So instead of doing this, if we set this, instead of 40,000, if we set this to 2,000, now 2 kilometers is our effective range. Now instead of having to multiply that by 10, we can just divide that into 2,000, which I think is better. But wouldn't that be 20? I think that would be 20,000 meters. So 1,000 in a kilometer. Yeah. It's too early for this stuff. Holy moly! I don't know why I'm having difficulty with this. Basic math. Yeah, that should work. Yeah, 2,000. That's our height in meters. So it'll divide this into that. Perfect. So that will give us precisely where the altitude that we want. So now within that scale, there we go. That's what I was thinking. So now within that scale, we can do, say, 100 meters. So that gives us an effectable roll of 20. So now we can say between 0 and 20, we can have a different size of circle. Okay, there. Now we've got the full, right? So because we have this, we have X, Y, and then we have the radius. And so when we print this radius, right? This is going to be X2, and this is going to be Y2. It'll be the same as the end of the line, and then our radius. So we can start at half a pixel. So if the altitude, if the number is, let's say, if it's less than, 10, or we could say less than 5. It's that big. And then that gives you a scale. So now it's between 0 and 500 meters. And then you can still print the actual altitude number. So I highly recommend if you still print the altitude number, you'll get an exact altitude. And then what this will do is this can just kind of scale the size of the object on the radar based on that. That's pretty much it. And then you can say, and then we have to, because this is its own function, just like that. So it'll read that number. If it's less than 5, it'll make it this big. And then we can copy this, and this is how we build our scale, right? 2, 3, 4. We have 8,000 lines of code, so we can do this. Is less than 10 and greater than 5. We can say less than 15 and greater than 10. And we can say less than 20 greater than 15. I think that'll work. Line 42, alt number B. Line 41. Oh, do I need another? Right, this is its own expression. Is that right? Yeah. This is its own expression, and then this is an expression, right? So this is an expression. It'll do that. Can we get rid of it? Can we do that? No, that has to be its own expression. That's right. Wrapped within that expression. Okay. I always get that mixed up sometimes. Oh boy. Okay, so yeah, so now when it draws, it'll draw a circle based on that altitude number. So let's just test this really quickly to make sure that that works. Spawn it in. Probably not, but we'll try. Well, it's called nil value. 10. Why is that? What is that? Does the radar come directly into the... It does. This is the radar in. Oh, let me take a look. Let me take a look. It might be the capital T on there. Let me take a look. No, because it's this one here that we did. Yeah, it's the capital T. It's supposed to be lowercase t. Spelling. That's this one. The language one. There we go. There we go. Let's restart this music. This super cool music going on here. Holy moly. This is a 1-hour Lua video. Alright, update that. Spawn that. So yeah, so once you have that number, there's a lot of things that you can do. The other thing that we can do, so now this is top down, right? This is looking at the object from a top down perspective to compare number with a Boolean. Did I say get? Did I say get Boolean? Interesting. I wonder if it's, oh, because this is all distance. Distance, and then this should be B. F, H. Alright, let me see what that error was. Let me see where it was here. What have I done? Draw failure. Attempt to compare number with a Boolean. Oh, I see. It doesn't like that? Doesn't like that? I don't think it likes that. But the out number. All right, maybe let's see. Let's break it down and see what's going on. Now, like I say, I'm not I didn't read a book about programming, Lua, or anything like that, and I'm definitely not a math whiz. Oh, there we go. So I just kind of want to throw that out there, like, if you're noticing errors, that's why. Hey, double check your work, right? Double check your work. I double check it usually after. You know, if I'm struggling in a video, I'll be like, oh yeah, I'm dumb. So we can then take this and let's make this 10. If it's greater than 5, okay. So now what I need to do is I also need to check the math on the scale, because that might not be wholly accurate either. Because if it gives you the exact number, let's see. Oh yeah, there it is. Look, there it is. Must be, my altitude must be greater than 5. There it is. Yeah, it works. It works. So let's find that scale. It's drawing the circle, but it should be drawing a circle full. Draw a circle, and then do we need to draw? Yeah, capital F on that one. Draw a circle F. So that will draw a full circle if it's less than 5. So now let's see what happens if I'm greater than 5. Actually, hold on a second. Let's see. Yeah, if I'm greater than 5, it shouldn't draw anything. Oh, there we go. Now, obviously, I can't check to see if it detects me. So I'm greater than 5. Whoa. But I might not even, like, the radar is way up there, so I might not even be within the detectable range. And as you can see there, it's giving me the number as in negatives. So what we should do is, I should output that number. We could just draw on the screen, we could just draw the text. Then this, so what you're watching now, basically what all I'm doing is I'm just like debugging, right? So then it's gonna do that, and then what we can do is it'll draw the circle, and then we can say draw text, but let's change the color of this to, I don't know. I thought white was 255, 255, 255. And then this is going to be alt number, just like that. And then we need format string dot format. And then what did I say we needed? The percent 0.0f, just like that. Now, do we need these? I'll just check the other radar I have. I used to have a little cheat sheet, but it's gone. Just like that. Comma, that within the quote. Okay, gotcha. Alright, so we should be able to do that. Oh, and then I say greater than. So we must be less than. So let's see what the actual number is giving us. If it's negative, then I'm not too sure. Maybe we have to multiply it by -1 to turn it into a positive number. That I'm not sure. So this is kind of where like -0. -0. Strange. Okay, so now what we're gonna do is, let's not do the math on the number, and let's just take it as it is. Let's just take it as it is. And that should just give us actually, that's what it was doing. It was just giving us the altitude number. Yeah, without the division. Now let's see how it works without the division. So it should tell me in meters where I'm at. I guess that's probably why I was converting it probably the wrong way. So it should tell me in meters. This one's telling me I'm at -5. This one's not saying anything. So I'm going to assume if I go up a little bit higher. Oh look, the number went positive. How strange. And this number hasn't moved at all. Well, there you have it. There you have it. Why is it 0? It should be 0. Let me double check. I gotta double check everything here. So maybe this needs to be a quotation mark in order to get that number. Then I'll check the other one and see how. See what I did. Huh. How strange. Okay, so let's just get it to print this number outside of a, just right here. Okay, so we have that, and then before I spawn it in, I want to check the other microcontroller just to see. Yeah, same thing. And then alt final is right there. Oh, I multiplied it by 10. I multiplied it by 10, yeah, because it's meters, and that brings it in, yeah. I was doing something. It could be this. It could be this number here. Maybe that's why I had to multiply it by 10. So instead of giving it to, yes, okay. Let's not tell it to give us the number like this. Let's go, how many decimal places? Let's give it to 2 decimal places, maybe. I think we can go up to 6. So let's just see what it's doing. Let's see what it's doing there. Oh, there we go. So I almost got a reading on that. All right. We can go up to 6 decimal places. So let's go to 6. There we go. It's giving me 4 numbers. Interesting. So this whole number here could be considered our elevation number. I don't know what we do with these other numbers. Pretty accurate though. That's pretty accurate height. Is it in centimeters? So I wonder if it's in centimeters or in feet. I wonder what that is. I would have to multiply it by 100. To get that into a whole number. Man, something's not making any sense here. Something's not making any sense here. Something's not making any sense here. So with this radar here, what do we have this? This is the rotation, which doesn't matter. Okay, we take our... Oh, this is number 19, which is fine. 17, 18, 19. Number 3. And our distance, which is our detected distance. Yeah, and that gives us our altitude final. I wonder maybe if I've written it wrong. No. Except for that. Oh, you know, this is... I'm dividing it by 48 here. Dividing it by the radius. That's probably why. That's probably why we're doing this. For this. Because I didn't want to do it down here. Aha! Yes! So then if I take distance, because it equals that, so what I need to do is multiply it by 48. Yeah, I have to divide it back out. Right? Oh, that's my fault. 48. Let's see if that's going to work. And then I don't need to do this here. We won't do anything to it. We won't alter the number at all. And we'll go to 6 decimal places and we'll see what happens. Aha! See? Sometimes you kind of... You know, it's important. We can print it so we can see the number, and that helps us kind of... There we go. There we go. Now something different's happening. What? I don't know. That's probably why I multiplied it by 10. It's weird that it's giving it to us as a negative number. Everything I build is backwards. It's all backwards, and I end up having to multiply it. Okay, so that kind of worked for there. That gives us the number. If we multiply it by 10, then, and we'll give it to, if we multiply it by 10, that'll turn it into a whole number, and now it's exactly like the other radar was. This one's a lot more accurate. This one's a lot more accurate. Okay, so let's not do the dividing in and the dividing out part. That just doesn't seem to work too well. This here. Here, we'll do this. We'll just copy this because we have the code for it. I'm just trying to be as accurate with the inputs as I can be. And I can change this right here, but I just want to make sure that everything is everything works, you know. I just want to make sure that I'm considering all possibilities. And I'm trying to be as fair as I can be in this super long video, which was kind of just supposed to be a quick response. a quick response video. Oh boy. Come on. Hey. No, I don't know what's happening here. Something's happening. right, so it gave me a 2. I wonder if that's 20 meters. I guess I have to check the elevation here. I need an altimeter to tell me kind of where I am exactly. Let's see. Seven meters above sea level. So when this detects me, it should be 7 meters. And it's not, it's 0. Will all be. Will all be. At least that was giving me a 3. Now, I wonder, okay, now let's consider one more thing here. Let's consider one more thing here. Let's take the radar and let's do this with it. Here, let's do this. And we'll merge it here. Can I not do it like that? Alright. Alright, we'll restart this one more time and then hopefully we'll get it. Huh, that's an odd purple line. Okay, so now as you can see, this one is telling me I'm almost at 7 meters. This one's telling me I'm at 2, but I multiplied. So there you go. I don't know where that purple line came from. Let me see, where's that purple line? What is going on here? I wonder if that's what that is. Let me see. Purple. No, that's more of a green. Alright, well obviously it's detecting a target. And it looks like it needs to be reversed now. From where it is. Interesting. Alright, so there you have it. So the elevation, so that means the radar needs to be basically right down. It's the same as, yeah, it's the same as the radar needs to be right at sea level to be effective. That's funny. It's one of them is detecting me anyways. That explains why it was giving me a negative number, because I was -5 below the radar. Alright, so that solves that issue. So if you want your radar to be accurate, it needs to be basically right on the water line. So we'd have to take this radar and cut it out and put it right on. We want it to be right on the water line, which is where everything else is. Cool. That explains. I'm starting to learn a lot more about this game every time I do stuff. There you go. Paste it, merge it. Yeah. So now that will detect, and then instead of telling it to oscillate, we're going to tell it to rotate. Clockwise. All right. There we go. So you see that? It detects an object, and now it gives us its height in meters based on where it detects it, and then it gives us a line. You see that? That's me. It's detecting something over there. That's pretty cool. That's me there. And then whatever it's detecting over there, probably the gun or something. So yeah, I just wanted to show that. There you have it. So now when we're doing elevation, that's basically how we add elevation to this. Then we just need to clean the radar up a little bit, and we'll be all good. So we don't need this one here and this one here. This is our super simple one. Now the other way that we can do that, and I will do this in another video, is what we'll do is we'll have our ship position, and then we will draw the angle. We'll draw the altitude angle, and we'll just draw a straight line to where the object is. And that way we'll be able to scale from the side where the object is, but that's going to take a little bit in another video. As you can see, I kind of have struggled my way through this one, but I got it done there. So that's how you do that. Thank you so much for watching this. Oh no, this Saturday video. And it's all been disconnected now. Cool. Yes, thank you all for watching the Saturday video. I hope that explained a lot. So let's just quickly recap what we did. So in order to add elevation and to be able to use that number so you can manipulate it, we need to take the distance, just the distance. No, where are we here? Yeah, we need to take the raw distance, and we need to take the altitude angle that it gives us, and then we need to take the distance and multiply it by tangent altitude angle, and that will give us the raw number. And then we just print the raw number like that without the decimal places. We can say string.format, whatever. Now, these each individual targets, what I would recommend is taking this here and whoops. There we go. When it detects the object, depending on the altitude number of the object, do whatever you're going to do, right? In our case, the altitude of where we were was one was 15 and one was like 35, so we're greater than 5, right? So now what we need to do is essentially find a scale that will allow you to make the circle larger or smaller. And so that's kind of up to you to determine. Like I say, when I do it, the effective range of my radar is 2 kilometers. So what I would do is I would take this number. Now that we have it, this is our accurate elevation, and try and find a way to scale that within 2 kilometers, either dividing it into 2 kilometers or whatever, and then finding out a way of printing it, right? When it's between these values, when it's between these values and those values. You're never going to be able to get, I don't want to say that you're never going to be able to get the exact size. I guess I could figure that out and see if I can scale that. Maybe that'll be yeah, we'll do a part 2. I'll see if I can do all those things in a part 2. Anyways, thank you so much for watching, and I will see you all in the next one.